So the first thing I want to write down on here is the following. So, ka, toa.
No, Missy, you have to do.
Okay. So in this case, sine would be opposite over hypotenuse.
Yes, you have to draw it that way.
Cosine would be opposite over adjacent. And tangent will be opposite over adjacent. So on this particular one, let's label our sides. X is on the hypotenuse side.
Wait, I have a question. Is it you always take so like does opposite and adjacent always change because like you're taking it from like okay, so I have B, so my opposite would be across from B and my adjacent would be across from
Right.
Or will be next to it.
Right.
But then up there, my adjacent will be 13 and my opposite will be my opposite will be 13 and then
Nope.
No, on number 2.
Yeah. So, okay, so let's talk about that first. On number 1, we're going to look at the angle 37. All right? So since we're looking at the angle 37, the side that is touching it that's not the hypotenuse. Okay, so if you're looking at the angle 37, the opposite's always the one that's not touching it. Okay? The adjacent is the one touching it that's not the hypotenuse.
No, but where do I start from?
So over here on number 2, here I'm looking at angle A. So what's the side not touching angle A?
So my opposite will be X and my adjacent will be 13.
Yep.
Okay, got it.
Okay? And this would be hypotenuse.
And then on 3, my opposite would be X.
Yep.
And my adjacent would be 5. So it can change. Okay.
Okay?
I got it.
And this would be hypotenuse. And then what is number 4?
For 4, my opposite. Hold on, time out. My opposite would be C to A.
Yep, so this would be my opposite with nothing on it.
Oh yeah. My hypothesis would be, or not hypothesis.
Hypotenuse.
Yeah, that would be 11, and then that one would be adjacent.
Okay, so on these problems, the first thing you need to do is label your sides. Okay, so that makes it a lot easier for you. So for number 1, we have an adjacent and we have a hypotenuse. Which one uses adjacent and hypotenuse? Cosine, okay? It's adjacent and hypotenuse. So I'm going to say cosine 37 equals 11. Wait, yeah, it's adjacent over hypotenuse. So I'm going to put a little 1 here. Cosine 37 over 1 equals 11 over x. The reason I'm doing that is you guys, you know how to solve proportions, right?
What?
How do I solve this proportion?
I don't know.
Cross multiply. Okay? So it would be 11 times 1, which is 11. And cosine 37x, or x times cosine 37. I can write that a little better. Okay? So now how do I solve for x? Yep, I divide both sides by cosine 37, so it'll be 11 over cosine 37, which happens to be what? 13.8? Yes?
Cosine 37 equals 11 over x, and then multiply both sides by 11, and then done it that way?
No, because 11's on the top, right? So you'd want to multiply by the denominator in that case. So you'd want to multiply both sides by x if you do it that way. I don't think so.
Hey, Mrs. Seaver.
Yeah.
How do you how do you decide that it's cosine? I know this is so like it's the adjacent over hypotenuse thing.
Yeah.
But how do you? I just don't get how that like applies to the answer.
Okay, so look at number 2.
Yeah.
What 2 sides do you have given to you?
Let's see here. So are you saying from x?
You have an x, which is on the opposite.
So yeah, that's your opposite, and then you've got your adjacent.
You have an adjacent and an opposite.
Mm-hmm.
Which of these 3 have an adjacent and opposite in it?
Well, okay. What are we solving for?
We're solving for x.
Tan.
Okay? Yeah, we need to find the length of x. But the only the only side that has an opposite and adjacent in it is tan. So I'm going to use tan to solve for this. I'm going to have tan 32, and I'm going to use opposite over adjacent. So it'll be x over 13. Yes, in the end it will be that, yes.
Okay, so do you have to have your calculator in degree mode?
Yes, it should be in degree mode. Okay?
Times both sides?
So I'm going to times both sides by 13.
Alright.
Okay? And whatever that is, I don't know, I didn't figure it out myself. What is it, guys?
8.12. Mine's not in degree, so I don't know.
Okay.
Oh, it is? Okay, 8.
You can round it up to the nearest tenth. Okay? All right. Let's look at number 3.
There's so many of these on the ACT.
Yes.
There's like a ton.
Yes. Number 3.
There was like 5 on one last week. That's a lot. It's just one type of question. That's
Opposite and adjacent.
We have an opposite and adjacent again. So which one are we going to use? Tangent again, okay? So tangent 50.1 equals x over 5. So I got to solve for x. Multiply both sides by 5. So what's my x end up being on this one? 5 times tan 50. So what is that? 4.2? What is tan 50? Okay, so I got tan 50.1. 1.19? I got something totally different than that, so
What did you get?
I think mine's in radians.
I got actually.
Yes.
6?
Yeah.
Okay. 5.5?
9.
5.9. Okay. 5.9 degrees.
I got 5.5.
5.97, so you gotta round up.
That's for the next one.
Okay. All right, so number 4. What sides do we have on number 4? Megan, what sides do we have shown on number 4?
Megan,
What sides do we have shown on number 4? Yep, adjacent and hypotenuse, right? So which one uses adjacent and hypotenuse, Sarah? Which one uses adjacent and hypotenuse? Cosine. So we're going to go cosine 60 equals x over 11. Okay? So if I multiply both sides by 11, what do you guys get?
I got 5.5.
5.5, yep. It says, for small angles, the length of an arc and the length of the associated chord of a circle are approximately equal. Astronomical measurements are commonly made by measuring the small angle formed by the extremities of a distant object. The moon covers an angle of 31 minutes when it is about 239 miles away. Okay, so what I'm looking at is this picture. That's supposed to be the moon. Here's the face. Okay?
Anton, do you have a cone on the side of your head? No.
Apparently,
Okay, so it's an angle of 31 degrees, and the distance was 239,000 miles. All right? From this information, estimate the diameter of the moon by finding the length, SK. So we need to find this length right here. Okay. Yeah. So that's the diameter of the moon.
or no, the length of, the length of, 239.
Yeah, I'm going to find x from here to here. once I find x, I'm going to do what with it?
Double it.
Double it, right? So I have a right degree angle here. I have 31 degrees here. So I know that I have an opposite. And then what is this side? Adjacent. So if I'm using opposite and adjacent, what am I going to use? Tangent. So tangent 31 equals x over 239,000. Okay? So I'm not going to go through and solve this, but that's how you set it up. So today's lesson is 5-2, and we're going to look at the inverse cosine function because, yes, I am recording it. So as you can see this first blank, it says you can read cosine to the negative 1x as the number, oops, whose cosine is x. The notation arc cosine, it's two C's there by the way, arc cosine is sometimes used in place of cosine to the negative 1. Okay? This is just the inverse cosine. Inverse cosine is another name. So there's three things you can see this as. Cosine to the negative 1, the phrase, the number whose cosine is x, arc cosine, and inverse cosine. Those all mean the same thing.
What's that word?
Just that one.
R,
Arc cosine.
R cosine?
Yep, I'll write it a little bit clearer.
Why would it be called an arc cosine?
Because it's inverse cosine, same thing. Arc cosine. No. It's the opposite. Okay? So, recall that the graph of the inverse of any function is the reflection image of the graph of that function over the line with the equation dun 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 x y equals x. So, remember that if I have say I have a parabola and I want to graph its inverse. What happens to that parabola? Here's my y equals x line. It reflects over that line, right? So now it's going to turn over to its side. Yeah, kind of like this. Okay? So the same thing can be said about cosine. When you are taking the inverse of it, it flips it on its side. Okay? So notice from the graphs below that the domain of y equals cosine x is the same as the range for the inverse of it. Okay? So here's our original. And notice that when I've reflected the line, the red one is the inverse of it. And the range is the domain of it. It is for cosine x is the same as the domain. I spelled that wrong. Domain. For inverse cosine.
So no one, no the other.
Yeah. Okay, the other thing I want to point out is notice that there's a limit on this graph. Where does it stop? At pi. So the y's is between what numbers on this one?
-1 and pi.
-1 and pi. And what is the domain on this one?
-1.
Actually, on this one it's pi over 2 and pi. So, yeah.
Yeah.
Pardon me?
What? Which graph are we looking at? She did not call on you. I know, but I'm confused.
Yeah, I understand. This should be pi over 2 right here too.
Okay.
But now look at this right here. What is the range that they give me? So really, the only section I'm really looking at is from here to here.
How do you know to flip it that way? Like what?
The reason I know to flip it that way is that I'm actually flipping the cosine function over this.
Oh, you're just making it.
I'm folding it, yeah. Think of it as this is your folding line, okay? Okay, so one of the things I want to point out to you is that whenever you guys see a restricted cosine function, and it says the domain is between 0 and pi, and the range is between -1 and 1, it's going to look like this. It's not even paying attention to this part of the graph. It's just on this side of the graph. And it's only starting here, and it's ending here. So really, it's just this box. You see that? So everything within that box is all it's paying attention to. Okay, so be careful when you see that restriction. Okay, evaluating inverse cosines. So the values of inverse cosine function must lie in the range of y equals cosine to the -1. That is from 0 to pi. So it's restricted. Or from 0 to 180 degrees. Yep. So one's in radians and one's in degrees. So if that is the case, and I'm looking at my unit circle, what quadrants am I looking in?
1 and 2.
1 and 2. I'm only looking at these right here, right? I'm not looking at the ones below. Okay? The ones below are not important to me with arc cosine. Okay, so look at number 1a. It says evaluate cosine to the -1, square root of 3 of 2 without a calculator and give the exact answer in radians. So what I am going to do right now,
So hold on.
so we know that we only want to use the section of the circle that is the top half of the circle, that's 0 to pi, right? And the only place that we have a positive square root of 3 over 2 for the x value is right here.
But we also have it at 330.
But that's not in the top half of the circle. Remember, we're only paying attention from 0 to pi.
Yeah.
So if this is my only place, what is it in radians that I'm looking at? Pi over 6. Okay? So when I go back over here, I'm going to say that my exact answer in radians is pi over 6. Good question. Let's go back and look at why. At 5 pi over 6, like, what is it? Is it positive or negative?
It's a negative.
It's negative. It's not positive. We need only the positive one.
So is the inverse of cosine just like the inverse of, is it just like the positive sign of?
So this one says evaluate cosine to the -1 at -0.5. This is also, you could say it like this, can you not? Say -1/2. Does that look more familiar? Okay. So let's go to our unit circle and find out where we have a -1/2.
Is that at 0 and 1?
Yep, it always has to be between 0 and pi.
Sorry.
Okay, so the only place that we have an x value of -1/2 is right here. That is at what? 2 pi over 3. Okay, so 2 pi over 3. Okay, so write this problem right here. I have a cosine of a cosine to the -1 of the square root of 3 over 2. What would that be? Yeah, so Autumn just said it. These two cancel each other out, right? So the answer to that is going to be square root of 3 over 2. You need to write this down in your notes somewhere. There's not this anywhere in your notes.
Is this like an identity theorem?
Yeah, basically the cosine and the cosine to the -1 just cancel each other out. Then it would be back to it'd be back to inverse cosine. Yeah, right. If the negative's on the outside of the parentheses, yeah. Okay. Okay, so let's look at another one. This one's a little trickier. And you guys need to pay attention because this is one that's like your homework.
Wait, time out. Stop. What is it in cosine negative 1 a half, negative a half?
That's from the left.
Oh, that's from the lesson. I thought she was just writing.
No, that's from that last problem. Okay, so now look at this one. You would think that the answer to this would be 210, wouldn't you not?
Yeah.
Eh. Where is 210 on my unit circle?
It's on the lower quadrant, and you can't use that quadrant.
Right, so I need to figure out,
Miss Kimber, can you never use the lower quadrant?
not in inverse, you can't.
You're wrong, Valerie.
So, what I need to do on this one is, first of all, know that my x value at cosine 210 is the same thing as saying negative square root of 3 over 2. Okay? Where is my inverse cosine at negative square root of 3 over 2? Where is it? 150.
Oh, wait.
Okay?
I bet you just got it.
On this one it says evaluate cosine negative 1 of negative 0.33333. Give your answer in degrees. Does it say give me an exact value?
No.
No, so you can use your calculator. Very good. So what you're going to do is look for the button that says cosine negative 1 on your calculator. Okay, and then you're going to put in that value, and your x should be estimate of 109.5. So putting this into your calculator, you should get an answer of 6.14.
No, it can't be equals. It has to be weight.
Yeah, it should be wavy equals because it's an estimate. Okay, so let's look at this application.
Wait, Miss Kimber, for all this stuff, do I need to have my calculator in degrees?
Yes.
Just like keep it in degrees?
Yeah.
Does it stay there, or do you have to keep changing it?
Keep it in degree at this point for this stuff.
Well, I know, but like, do you have to change it every
No,
time you
unless
use
you
it?
put
It should stay on there.
If you put it on and make the default, it'll stay.
Okay, so on this one it says the Landsat 7 satellite orbits the Earth at an altitude of 705 kilometers above the equator. It can only see a portion of the Earth's surface at any given time. Imagine looking at the cross-section of the satellite in the Earth as shown at the right. Okay? It says, point C,
Hi, Miss Kimber. You look pretty.
that point C right here is the center of the Earth. That H is the point in the horizon circle that can be seen from the satellite. And theta is the degrees that are found between the radius and this line right here. Okay? So, what we need to find right now is find the formula for theta in terms of R and A. Okay? So, what is this R and A? What part of the circle is that? I mean, yes, it's the hypotenuse, okay? So we know that this is a right angle. This is the hypotenuse. So basically our hypotenuse equals R plus A, right? Okay? So we know the hypotenuse. What is R over here? Is this our adjacent or our opposite? It's our adjacent because this is the circle right here that we're looking at, the corner that we're looking at. So we need to have adjacent over hypotenuse, which is cosine. So cosine theta equals R over R plus A. Okay? Because we know that we're using adjacent over hypotenuse. Those are the two variables that we know. We don't know anything about this side. Okay? So that's why we're using this. Now, if I want to solve for theta by itself, what I want to do is take theta equal to cosine negative 1 to the negative 1 power of R over R plus A. Okay, so that is going to be our formula. Part B says the radius of the Earth is 6378. To the nearest degree, what is theta? Do we know what A is?
No.
Yes, we do. Look back at the story problem.
705.
705. So what I'm going to do is have 6378 on the top, and then 6378 plus 705 inside parentheses, and then cosine -1 on the outside. Okay?
What is that? Why did you?
Theta ends up being 25.7 degrees. Okay, last one. To prop up this word, I don't know what it is, it's like a ladder, to the back of a stage, you have to have a 9-foot 6-inch board whose foot is 5 foot 3 inches from the back. Okay? So if I draw a picture of this, here's the floor, here's the wall in the back of the theater, and then I'm going to prop this thing up against the wall. Okay? And it said this part is 9 foot 6 inches, and the floor is 5 foot 3 inches, and I need to find at what angle that I put this. Okay? So,
Wait, I got this.
which one am I going to use? So, ka, or toa?
So,
Nope.
co, what?
Yeah, co. Because this is the adjacent. This is the hypotenuse, right? So the first thing I want to do, first of all, is I need to change this to all inches. 9 foot, or not all feet. 9 foot 6 inches is the same thing as saying 9.5, right? And then 5 foot,
Why can't you just say 9.6 inches?
because 0.6 is not, it's in inches. So, yeah, this is going to be 5 point what? Nope. 2.5. It's a fourth of a foot, right? 3 inches is a fourth of a foot.
Okay, so then you have 5.25 over 9.5 equals the cosine of theta.
Yep.
And then,
Or theta equals -1 cosine of the 5.25.
Right. So it'll be cosine to the -1 of this.
It's not actually.
Okay?